The lesson topic for this video is solving polynomials, and this is when we need to use a graphing calculator to find the first zero. Remember, zero here means solution. So this is going to seem like a very similar lesson as the previous lesson, but instead of giving you the first solution or the first factor or the first zero, any of those things, you need to find it yourself by using your graphing calculator. So the first thing you will do, and here are the steps down here, the first thing you're going to do is you're going to graph on your graphing calculator the function that you're given. The second step is we're going to find an X intercept from that graph, and we're going to make sure to use trace to verify that it is a whole number zero and not just close. So if you had this graph right here on your graphing calculator, we're going to find an X intercept by looking at it. Now it looks like there are 3 X intercepts that look like they're all whole numbers on this one right here. Okay, so you would pick any one you want. You would pick either 1, this is a 1 right here on the x-axis, or you'd pick 2, or you could pick -1. And then all I ask that you do is make sure that you use trace, so hit trace, and then that value for the solution that you were going to choose. So let's say you're going to choose this one here at 1. So you'd hit trace 1, and then if you do that, using trace, we're going to put 1 in for x. Make sure that you get y to be what? Think for a second what that would be. Well, y should be 0. Because in order for it to be an x-intercept, y would need to be 0. And if it's not 0, then it's not an x-intercept even, or a whole number 0, which is what we want to find, a whole number 0. After you find that first whole number 0, we're going to use synthetic division, step 3 down here, we're going to use synthetic division. And then after that, if we have x squared, we're going to either factor or use the quadratic formula to solve. And if we don't have an x squared, we're going to have to repeat steps 1 through 3 and find the next x-intercept that way. Okay, so let's look at an example. We have a function, x to the third minus 8x squared plus 5x plus 17. And we want to find x when f of x is 3. Again, remember that means y is 3, and we're going to try to find x. First thing I want to point out to you is that if you immediately put this function into your graphing calculator, it will not look like the graph I have shown here, because the first thing we need to do is put this 3 in for y and make sure the equation equals 0. So we're going to go ahead and do that. 3 equals x to the third minus 8x squared plus 5x plus 17. And again, this is a common mistake that people put this into their graphing calculator right away without thinking that, wait, we need to actually put 3 in for y. So we're going to go ahead and subtract 3 from both sides, and we're going to get our equation 0 equals x to the third minus 8x to the second plus 5x plus 14. Now, before we talk about putting this into our graphing calculator, I want to show you why we need this new method of solving, okay? Because last chapter and earlier this chapter, what we would do right now is we'd put a vertical line in between the first 2 terms and the second 2 terms, and we would factor to solve, factor by grouping. But if you can think for a second, you could do this on your paper if you want to, if we put this vertical line down here, the GCF over here would be x squared. There would not be a GCF over here other than 1, so plus 1, and would our parentheses end up matching? No, they wouldn't, which is why we need this new method. So now what we're going to do is we're going to put this into our graphing calculator, which I have done over here, and we are going to find our first zero or solution by looking at the graph and finding an x-intercept. I'm going to use my smallest positive value. It's typically what I use, but it does not matter which one you use. So I'm going to use 2 for my x-intercept, and I'm going to for sure hit trace and then 2 and check to make sure that it is a solution or a zero or an x-intercept. All those words work there, and it is. So we're going to go ahead and use that value of 2 right here as what we are going to use in our synthetic division. So notice we are not missing any steps in our polynomial. So we can write the coefficients 1, -8, 5, and 14. and then we are going to use 2 for our divisor. All right, so running through the synthetic division steps. And 0 is our remainder, which is good. It needs to be. And we're going to rewrite this now 1x to the second power, again 1 less than this right here, minus 6x and minus 7. And now we have a quadratic situation, and if you remember the directions on the previous page says if we have an x squared term, we're going to go ahead and either factor or use the quadratic formula to solve this the rest of the way. This is factorable. We have x times x gives us x squared, negative 7 and positive 1. They multiply to give us negative 7, and they add to give us negative 6. And so then we are going to use the zero product property, because remember we do have equals 0 right here. So if you wanted to include that right here, you can. And we solve each of these by setting them equal to 0. X equals 7. X equals negative 1. And remember, we have to go back to the fact that this 2 right here is another solution. So we're going to come down here and write and x equals 2. And we found that from our graph. There are our 3 solutions. Something different happens on the next page, on the next screen, so make sure you look at this last example on the next screen. Okay, now in this last example, we have our function, and we want to find x when f of x equals negative 5. So go ahead and write the equation and plug in negative 5, and then solve and make sure the equation equals 0. Okay, so we get 0 equals x to the 4th minus 3x to the 3rd minus 16x squared plus 21x plus 45. And again, definitely make sure you get that equation equal to 0 before you put it into your calculator, or you will get the wrong function. Now, I've mentioned that the Casio calculator is in most cases, a easier, quicker calculator to use. However, there is one glitch in their system, and it shows up right here. If you look at the 2 graphs shown right here, these are the same graph, the same function. It's this function right here. Now, you'll notice that this one comes through the x-axis 4 times and ends up going up here, whereas the Casio one comes down, comes back through twice, then through 3 times, and it doesn't have this last branch right here. It's the only glitch I've found, and it's only when there's a 4th degree polynomial and it's missing the last branch, and it happens in some cases but not all. Here's the thing, we'll make sure that none of our equations end up being affected or unsolvable because of this issue, and we will work at making sure we explain that in class as well. So here's the deal. You need to be careful. Again, we're looking for our first X intercept, our first factor, our first 0 by looking at our graphing calculator. Now it might look at first sight that maybe 2 right here on either calculator is a solution. It turns out it is not. If you use trace and hit 2, you're going to get y equal to 10. So it is not going through 2 exactly on this graph. Now, people with a TI calculator might try this value right here. The Casio calculator does not have that intercept because you don't have that branch of the curve. So TI people, that one will work. Casio, you don't have that one, but we can still go ahead and solve by finding an X intercept that does work for both calculators. So negative 3 on both of these. If you type in negative 3 for your trace, for your X value, you will get 0. All right, so that means negative 3 is the value we're going to divide by. So I'm going to write my coefficients: 1, negative 3, negative 16, 21, and 45. Notice I did not miss any: x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the 0. And we're going to divide by negative 3. All right, go ahead and do your synthetic division. And we get 0 for our remainder, which is great. And we're going to rewrite 1 x to the third power. Again, it is 1 less than this, so this is x to the fourth, so this will be x to the third. Minus 6, and we're just going to drop x to the third down to x squared, plus 2x plus 15. All right, now if you notice, if we tried to put our vertical line right here, because this is a 4-term polynomial, and we solve that by grouping, we factor by grouping, excuse me. If we put that vertical line in here, we are not going to get parentheses that match. So this is still not factorable. So as you saw on the first screen, it says if it is not a quadratic that is factorable or a factorable situation, then we need to do steps 1 through 3 again, which means we need to find another x-intercept from our graphing calculator. So I took our new third-degree polynomial and I graphed that on my graphing calculator. And if you look at that function now, you'll notice that we have some x-intercepts again, and we need to find a whole number one. Now if you use trace and hit 2, for example, because it kind of looks like 2 might be a solution. Okay, hold on one sec. It looks like 2 might be a solution. If you put that in for trace 2, it is going to give you y equals 3, which is not what we want. So then maybe we try 4. Or is that 5? 1, 2, 3, 4, that's 5, sorry. We're going to try 5 and use trace to check it, and it is a 0. So x equals 5 is our next 0 that we are going to use in synthetic division. So we need to actually do this again. 1, -6, 2, and 15, and we are going to divide this by 5. Again, going through the steps of synthetic division. And we get 0 for our remainder, so that's great. And we are going to rewrite our polynomial. So 1x squared, now this time what we're doing is we are taking this x to the third power and dropping it down 1 to x squared, minus 1x minus 3. Now if you look at this, you might think, okay, let's try factoring, but you'll notice that we need to get -3 when we multiply our two numbers if we were trying to use the parentheses, right? And the only factors of -3 are 3 and -1, or -3 and +1, neither of which will give me -1. So this is not factorable. And if it's not factorable, what do we need to use? We need to use the quadratic formula. Now for the sake of the length of this video, and we're getting on about 13 minutes I think, I will assume you can finish this problem by using the quadratic formula and finding all of your solutions. Remember, to find all the zeros of this polynomial, we have to remember that -3 is one of our solutions, 5 is one of our solutions, and then the 2 answers we get when we use the quadratic formula will be our other 2 solutions. We will have 4 solutions.